So I'm going to do another example now with a different function. We are going to do the integral from 1 to 3 of e to the 1 over x dx. So this is what we're going to approximate. We're again going to use n equals 8. Okay? So I've written all 3 rules on the board here so we can just kind of write underneath them. In order to do it, of course, I have to first figure out what my delta x is, right? Since n equals 8, then delta x is 3 minus 1 over 8, right? So 2/8 or 1/4. Okay? And my f of x is then this e to the 1 over x. I'm taking the interval from 1 to 3, and I'm dividing it up into 8 pieces, right? Each of 1/4, so you can see what that's going to be. Right, so 1/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4. Right? So those are my points. 1 is x naught, 3 is x8. Okay? So that is the partition. Now, of course, for my midpoint rule, starting with my midpoint rule, we're going to put M8. Delta x is 1/4. We need the midpoints, right? So obviously, this is going to be half of a quarter is an eighth, so this is going to be 9/8. 11/8 all the way here, and of course 3 would be 24/8, so my last one would be here 23/8, etc. So those are my midpoints, so I'm just going to put those in. So each of those points, each of those midpoints is going to go into my function. Now my function is e to the 1 over x, right? So I'm just going to get these reciprocals here. E to the 8/9 plus e to the 8/11 plus all the way, the last one would have been e to the 8/23. And when I figure all this out, my number is 3.5152. Okay? So that's the midpoints. Of course, that gives you the midpoint rule. My trapezoidal rule, I basically do the same thing, right? Because it's delta x over 2, now this is 1a. And now both these two, as we said, are actually just taking the endpoints of the interval, so I don't need those midpoints anymore. E to the 1, right? X naught is 1. Plus 2 e to the 4/5 plus 2 e to the 2/3 plus all the way. The second to last one is the 11/4, and then my last one is 3. Right? And then I wrote down what that was. Over here it works out to be 3.5349. All right? And then for my Simpson's rule, again, delta x over 3, so I get 1/12, right? Wait. Yeah, 4 times 3 is 12. Yay! Okay, so then I have again e to the 1, but now I've got 4 e to the 4/5 plus 2 e to the 2/3 plus 4 e to the 4/7 all the way to e to the 2/5, 4 e to the 4/11, and my last one is e to the 1/3. Anyway, I worked this one out. It's 3.5224. Okay. So really this one is actually going to be much closer to the answer, but you can see 3.5 is absolutely going to be right. Anyway, 3.5 something. So that's that example. Now in my next example, in fact, we'll look at this again, and we will talk about how close these numbers are, or an upper bound for how close these numbers are to the actual value.